Hello and welcome to Group 10's REA605 proposal presentation starring Yasim, Shadi, and myself, Ilya. Today we're going to be talking about our proposed solution for our REA605 project. We'll be talking about our project objectives of how we're going to deliver them, a task breakdown of all our tasks, the phases involved, our description of the proposed work that we're going to be doing over the course of the next 2 semesters, the management plan of what we're going to be doing, the deliverables that will be the outcomes for our project, and a Q&A session afterwards. So with that in mind, let's get started. So our group's proposed solution is to create a newly automated Advanced Persistent Threat, or APT, emulation tool, which will simulate various enterprise attack techniques based on the MITRE ATT&CK framework on a specific network infrastructure that will, as a result, simulate the presence of a specific APT. This will be in conjunction and in complement to the tool called Endgame Inc./RTA, which is available on GitHub, and it will serve as a basis for our own scripts that we'll be running. Our proposed solution will allow users to have a better understanding of how APTs work and the methodologies that they use when trying to attack a system. This will also, as a result, allow users to test their own environments against the specific attack scenarios that these APTs employ on their own. As a result, this is also based on a previously done evaluation back in 2018 by the MITRE ATT&CK organization, and they did a full evaluation on how these APTs attack a system. So this is what we'll be basing our own solution off. So the objectives of our project proposal is to create and write scripts for an individual APT, which in this case will be APT3, also known internationally as Gothic Panda. Our proposal will introduce scripts that will emulate an example scenario that was done by the MITRE ATT&CK group on the presence of this specific APT on their test environment. What they have done before is manually run each specific enterprise attack technique on their test environment, which is time consuming. What we propose to do is make our own scripts which will execute these techniques for each pattern, such as during the initial discovery phase of the scenario, the persistence, the credential access portion, and so on. This will, as a result, will automate the process of running each attack technique and therefore make it easier to run. And as a result, people will be able to use our proposal for educational purposes and learn more about how APTs work when attacking a system. Now I'll give it over to my partner Shadi, who will go over the task breakdown.
For the task breakdown, we have created a simplified version using a tree structure to make it easier to follow. To create the automated persistent attack based on Gothic Panda, we split it into 3 subparts, which are creating test environment, writing the scripts, and documenting findings. Now, the first part, which is creating a test environment, has 4 subparts, which are creating and configuring Kali machine with Ansible, building and configuring the servers, building and configuring the clients, and building and configuring the visualization machines. The servers will consist of 2 Windows Server 2012, and the clients will consist of 3 Windows 10 64-bit machines. And for the visualization of the events and viewing security logs, we will be using Security Onion, which has tools such as Elasticsearch and the Hive to assist us in this process. The second part, which is creating these scripts, will consist of everything from initial compromise to exfiltration. Those scripts will be written in Python and pushed through Ansible to be tested against our test environment. Now finally, for the last part, which is documenting the findings, we will, through the use of Security Onion, we will have real-time data for what is happening, and we will record these events as well as record the progress of events outside the test environments to create a detailed report of our project. Yasim now will speak in more detail about the breakdown.
Thank you so much, Shadi. Now I'll be talking about the project phases and tasks. So our first phase of the project is to establish a test environment. So we have proposed to create 3 different domains, which consists of the attacker domain, the client domain, and the server domain respectively. So our attacker domain will consist of a gateway VM, and it will allow internet access using routing and firewall rules to all other machines on the network. Then we have our Python scripting agent, which will be responsible for installing and configuring Ansible, which will help automate the scripts and send them to Windows machines. And then next, on our apparatus, we have the Security Onion VM, which will configure routing and firewall rules to allow connectivity to other VMs, configure and deploy sensors on victim domain virtual machines. So our client domain will consist of client A, B, and C. They will be part of our Active Directory domain users, whereas our server domain will consist of the Active Directory domain server, which will be hosting the Active Directory service, and they will all be configured to communicate with one another. So our second phase of the project consists of writing APT Technique Python scripts for APT3 specifically. So some of the phases that we propose to implement are initial compromise, initial discovery, gaining privilege, accessing credentials, persistence, and exfiltration. So, which brings us to our next phase, which is execution of all the scripts that were mentioned earlier. So these scripts will be pushed to Windows machines using Ansible. And then the fourth phase of this project is analysis and reporting. So documenting all the results and developments of the process, storing like log files and visualizations of the events using Security Onion tools.
So now I'll be going over the test environment that we'll be implementing when running our proposed solution. So what we have on the left side is the victim domain, which consists of both a server domain and a client domain. The server domain will be hosting 2 Windows Server 2012 virtual machines that will be individually hosting separate services. For instance, server B will be hosting an Active Directory domain controller server, whereas the other one will be a file sharing server. Now, the server domain will be running on its own host machine, as our test environment will be a distributed topology. On host B, we'll be hosting the client domain. On the client domain, there will be 3 separate Windows 10 VMs that will serve as client machines to the servers that we've discussed previously. Now, on host A, on the right side, this will be where our attack domain consists of. We have one machine, the VM on the left side, that acts as the gateway for the victim domain. This is where they will get the internet through as a gateway. On the same domain, we have a security onion set up in order to have sensors deployed on each individual victim domain machine, and therefore pick up on any of the intrusions that's being occurred. Now, lastly, we have our Python script agent machine, which is a Kali Linux machine. This will both not only host Ansible in order to propagate the scripts throughout the entire network, but it also will have Metasploitable framework in order to deliver some of the specific payloads. As such, this is where our scripts will be hosted, and from there it will be launched through Ansible to the victim domain. Our test environment will be running on 3 separate physical machines, not only to closely resemble a modern business infrastructure as closely as possible, but make it more efficient to distribute and allocate network resources more efficiently. For example, having one machine run 5 VMs will be too costly and therefore strain the host machine on resources such as RAM and CPU count. As a result, we're going to split up each domain on their own physical host machines. Now, each machine will either consist of a VLAN network to communicate with other VMs, or it will be connected with a virtual bridge to a physical switch, therefore allowing it to be routed back to the gateway over here. And as a result, all the VMs here should be able to have internet access and communicate with one another. Now I'm going to give it over to Shadi, who will explain one of the scripts that we'll be running as part of our solution.
This is a sample persistent script that can be sampled in our project. It is a sophisticated script that uses psexec. It first attempts to find a log in which the phrase must be run as a non-system user exists. This allows it to identify the user with the system privileges. It removes existing profiles from the system and removes log files. It executes an executable file that allows the script to be persistent. Next step is waiting for the persistence to establish and reads the log file back. It then triggers a logon to allow the persistence to run, and it logs you onto the system. Waiting for the logon to finish, it has a sleeper timer of 30 seconds, after which it deletes the user that was created previously. This next script is a way to call the PowerShell with suspicious command line arguments through the creation of empty scripts which allows it to gain the process ID of PowerShell.exe. Now I'm going to pass it on to Yasim to speak about the phases.
Okay, to quickly recap, we're going to be using a high-level diagram consisting of all our project phases. So in the first phase, we configure our test environment and we allow SSH and disable all the firewalls. Followed by the second phase, wherein we create our Python scripts using different techniques mentioned earlier for APT3, followed by execution of those scripts in our test environment, followed by phase 4, which is analysis and reporting of all the artifacts generated by Security Onion. So if there is a issue with our script, so we go back to troubleshooting phase, which is phase 2.5, which leads us to phase 2, wherein we fix up all the parameters that are necessary and needed to be fixed. Once the parameters have been fixed, we go to our execution phase, and then we go to our phase 4, which is analysis and reporting.
For the deliverables of this project, we will be submitting Python scripts, which will be uploaded to GitHub to Endgame Inc. RDA tool, and also be available on our group website. We will also submit a post-simulation report, which will include Security Onion logs, Kibana visuals, and the Hive security reports, along with our progress notes and the methods we used to get to our final goal. Thank you for listening, and if you have any questions, please ask.